we are going to discuss a very interesting topic of data structure, that is queues. What is queue, where we are using queues, what is the implementation of queue, we are going to discuss in this session. So we will start. So after this lecture you are able to understand, number one, understand the concept of queue and its FIFO. FIFO, first in first out behavior of a queue. Number two, identify and explain the basic queue operation. Whatever operation we are going to perform on queue, we will see in this lecture. Next, write and interpret the structure algorithm. How we can implement a queue, we will see in this lecture. And lastly, understand the error condition like queue overflow or queue underflow. So these are my learning outcomes of this session. So we will start with a queue. So queue. So the first question is, what is a queue? So queue is a kind of data structure which is similar to stack. In my previous videos I explained what is a stack. So here we are discussing about queue. So queue is a data structure which is similar to stack, with the primary difference that is the first item inserted first and removed, right? That means it depends on the function, or I can say depend on the strategy of FIFO. FIFO means first in first out. Which element is come first, it will serve first and go out first. That this is the strategy which is known as first in first out strategy, right? Where stack is based on LIFO. LIFO means last in first out. So this is the basic difference between queue and stack. Here for your understanding, I will show a diagram so that you can understand much properly. So you can see here there is a diagram. In this diagram you can see a queue where the first person is using ATM, right? So it's the first person who is using ATM, right? So this is the first one, second, third, fourth and fifth. We have 5 peoples are there, and he's come firstly so that he will serve firstly. That means this strategy is known as first in and first out. He will process first and then he will go out from the queue. That means it based on first in first out strategy, right? Whereas if I'm talking about the stack, in that stack the first item will inserted, but whenever we are talking about the getting an element from the stack, the last element will go first, so that stack work on the strategy LIFO, last in first out. Whereas when we are talking about queue, it is based on FIFO, that is first in first out strategy. I hope now you understand the concept of queue. Okay, then we will go to the next slide. So here is a technical representation of a queue data structure, how it looks. So here I have 1, 2, 3, 4, 5, 6 elements in my queue, and here 2 operations are there. One is Deque, the second one is Enqueue. You can see in the slide that we have some basic terminologies. So number one, if we are talking about front or head, and the other one is back, trail or rear, right? So queue, so the first element, so this is my first element, and in this case this is the last element, right? So if I want to add one more element to my queue, it will comes here. So from the tail side, from the back side of the queue, I can insert an element. And if I want to remove an element from the queue, we will use front, or I can say head. So I'm removing this 2 from the head. The operation of removing an element from the queue is known as Dequeue. And when I want to insert an element in my queue, that operation is known as Enqueue. So I have 2 basic operations with queue data structure, that is Dequeue and Enqueue, right? And here I am implementing my queue with the help of array. So this is array with the help of array, right? So this is queue data structure, right? Now I will show you an animation so that you can understand easily the concept of queue. So here you can see that I have a queue, right? And I can do some things so that you can understand the concept. The task is the letter in the word is encrypt, and I want to store a queue in a random manner. Here is a queue, here is another queue. This queue is known as QA and this queue is known as QB, right? Now I want to observe the operation performed to display the letter in their correct order in QB. So to form the actual word. So now I am starting this animation for you. So here you can see. So here I am resetting this and you can see what is going to happen. So demonstration start. Now you can see there is a Q, QA and QB. Here with the help of this, it synchronizing the word of encryption, and after that it will convert the word encryption in QB. So every word is come here according to the right sequence. E, N, C, R. Now we have 3 letters and now it will come here Q and P, and the 2 words are remaining, 2 alphabets are remaining. So here the rare is incremented from 1111 word according to the 111 word. Now when the word is set, so the front is pointing to the E and rare is incremented to the last alphabet, that is T. So rare of the Q is pointing here and the front of the Q is pointing to E. So in this way you can understand how rear and front is working. If you want, I'm again resetting it. Again you should see this so that you can easily understand the concept of queue. So first the QB is empty and I'm searching for E. So the queue is decreasing and try to search the word E. So now E is here in QB. In the same manner, again and again we are searching for the right alphabet, and after that we are searching the right alphabet and putting in the QB. So in this manner I have all four letters, that E, N, C, R, then Y. After then 2 alphabets are remaining, P and T. Now you can see that my word is synchronized. It is here. So in this way you can see how my rear and my front is working. Now we will go back to my PPT so that I can explore more to you. So here we have 2 major operations. One is Enqueue and another one is Dequeue. one is Enqueue and another one is Deque. Enqueue means the operation which is involved for adding an element to the queue, right? Adding an element to the queue, or from which place? It is very important to understand, from where. It's attaching, it's inserting a new element from the rear. When we are doing Enqueue, that means inserting an element, we are putting an element in the end of the line waiting to be processed. So this operation is known as Enqueue. And another one, when I want to remove an element from the front, we are using that function. That function is known as Dequeue. Dequeue operation removes an element from the front of the queue. So this is very important. Why we are removing an element from the front of the queue? Because my queue is working on FIFO, first in, first out. So here you can see with the help of diagram that whenever an element is inserted in queue, so we are inserting from rear, right? The queue increases rear index, later use, and store that element at the rear and of the storage. If rear and reaches to the last index, then we cannot insert another element to it. What it means? For an example, I have a queue. And I want to insert a value, right? So I have insert some values like this. Now I want to insert one more element with the help of Enqueue operation. So now I inserted 9 at the last storage of a queue. Now again I want to insert another element, so I cannot insert another element because I do not have memory space left in my queue. So before inserting an element, I have to check that my queue is empty or not. My queue have another storage place for inserting an element or not, right? So this is an Enqueue operation. Whenever we are talking about the deletion, so again we have to check that if I want to delete an element from the queue, is any element is remaining to delete in a queue or not. For an example, I have a queue and I have certain elements in it, maybe 5 and 8, and I want to delete it. I delete 5, I delete 8. Now again, if I want to apply a delete operation and I do not have any element to delete, so firstly I want to check that my queue is empty or not, right? So the Dequeue operation remove an element from the front of the queue, right? From the front, that means tail. So this is rear and this is front. So whenever I want to delete an element, firstly I delete this one, then this one, then this one, and comes to the rear for deleting the last element present in my queue, right? I hope these two operations are very much clear to you. Now we will go to the next slide. So array representation of queue. Here I am implementing my queue with the help of array. So you can see that when I am declaring an array, and so this is my front, this is my front, this is rear, and this array structure, is known as queue. Whenever I want to delete an element, I will use front. Whenever I want to insert an element, I use rear, right? You can see here, this is after queue, after inserting a new element. So here I am putting my new element from the rear side, and when I want to delete it, I'm deleting this 12 from the front side and increment my front by 1. Firstly, it's pointing to 12. Now, when I delete this 12, my front is pointing to 9. That means front plus 1 here. So, this is an array representation of an queue. After understanding the concept of queue and Enqueue and Dequeue, we will see here, we can see an algorithm of an queue. So, firstly, in my first step, first we have to check the rear is equals to -1. Firstly, we have to check what is max. Max is a size. Max is a size because we are using array. So, obviously, the index values goes to 0 to max minus 1, 0 to size minus 1, right? So, firstly we have to check that rear is equals to max minus 1. If it is true, if this condition is true, then we will show a message that it's overflow. That means there is no space remaining for inserting an element in my queue, right? So, we have to go to step 4, that is exit. We cannot insert an element. Initially, my both pointers are pointing to -1. If this is the condition, then we will check if rear equals to -1. If it is true, that means we have a queue but we does not enter any element to it, then we put front and rear equals to 0. That means here I have a queue and my rear and my front both are pointing on the position. Which position? 0th position of an array. So this is an array and they both are pointing to the 0th position. If they are both are pointing to the 0th position, then we can enter the element to it, right? Else, if they both are not pointing to the 0, then we incremented rear by 1 and put any element. Maybe so initially front always point to the 0th position and rear will move 1 by 1 whenever we are inserting an element. So this point is also clear to you, and then we will put the number and after then exit. So this is an algorithm for entering an element via a function known as Enqueue using arrays, right? I hope this is clear to you. Now we will go to the delete option. Now here you can see an algorithm for deleting an element from the queue. So I have a queue and I have some elements in it, maybe 3, 5, 8, 7. In this case, this is my front and this is my rear, right? And queue is working with the funda of first in, first out. So the 7 is come first, so it will delete it first, it will process first. So here we have to check if front equals to -1 or front is greater than rear, then we will give a condition underflow. That means there is no element. If front is equals to -1, that means it is pointing here, because this is 0, 1, 2 and 3. And if front is equals to -1, that means it is here somewhere. If it is here somewhere, that means there is no element remaining, or there is no element in a queue. That means the message will comes to you is underflow. That means there is no element. If this condition is not true, then we will go to the else part. Then we will the front of Q, the value of front of Q is assigned to the variable that is well, and we delete this element. And front is incremented by 1. Now front is pointing here, right? So front equals to front plus 1, and then we will exit. So this is an algorithm for deleting an element from the queue, right? I hope this is also clear to you. So now I have two assignments. After discussing the concept of queue, Enqueue, Dequeue, and the algorithms of queue, I have two assignments so that you can sharpen your wisdom about queues. So write a program to create a queue using array and perform standard queue operations. Standard queue operation means I'm talking about the two major operations. One is Enqueue and next is Dequeue. The next assignment is give a queue and reverse its element using stack or recursion. Just whatever is comfortable for you. What I want to do, if I have some values like 1, 2, 3, 4, 5, you should write a program so that you can reverse a queue and your output will be 5, 4, 3, 2, 1. So these are two assignments, right? After my session, I want to summarize my session in these following key takeaways. Number 1, a queue is a linear data structure where insertion happens at the rear and deletion happens at the front, right? After then, it follows the FIFO operation, FIFO principle, that is first in, first out, where the first element added is first and to be removed also first, to be processed also first. The next one is QR, we used in various real-time scenarios like CPU scheduling, printer spooling, and handling request in a server. And the last one is proper handling of overflow and underflow condition is essential for the stable queue implementation. So these are the basic key takeaways of my session. I hope all the concept is clearly understood by you. So thank you very much for your attention. All the best. Keep learning.